Welcome to the deep dive. Today, we're getting into a topic that it sits right at this strange intersection of our deepest, most personal emotions and, well, the far edge of
Yeah, it
science.
really
We're
does.
talking about dog cloning, the idea that you could, bring your best friend back.
Or at least a version of them, a genetic twin.
Exactly. And we've done a really comprehensive look at the research here, drawing a lot from Dogazilla magazine to unpack it all. We want to get into the science, the mechanics of it, the global laws, and, the real-world stories of people who've done this.
It's a fascinating and I think a really controversial world.
It is, because for so many of us, a dog isn't just a pet, right?
Mm-hmm.
They're family.
Mm-hmm.
And the idea of losing that connection, that specific personality, it's devastating. And that grief, that's really the engine behind this entire industry, isn't it?
It's the whole reason it exists. At the end of the day, past all the high-tech lab equipment, dog cloning is a very advanced and very expensive response to loss.
So just to set the stage, what are we talking about in the simplest terms?
In simple terms, it's a way to create a genetic copy of an existing dog. You're using advanced science to preserve those genetic traits, and for the owner, the hope is to kind of extend that unique relationship.
Okay, so let's get into the nitty-gritty. I think a lot of people hear cloning, and they just picture a sci-fi movie. But how does this actually work?
Right, it's not a magic button. The core technology is called somatic cell nuclear transfer. It's a mouthful, so people usually just say SCNT.
SCNT.
Yeah.
Okay. And somatic cell, that just means any cell from the body that isn't a reproductive cell, right? Like a skin cell.
Exactly. That's the most common source. So step one is getting that genetic blueprint. Scientists take a small tissue sample from the dog you want to clone, the donor, and they isolate a cell.
And the dog doesn't even have to be alive for this part, which I found incredible.
That's true, but the cells have to be preserved very quickly and correctly after death. Time is critical. So they have the nucleus from that skin cell, which contains all the DNA.
Okay, so they had the blueprint. What's next?
Step two is preparing the egg. They take an unfertilized egg cell from a different dog, a donor egg, and then very delicately, they remove its nucleus.
They scoop it out, basically.
Yeah, you can think of it that way, yeah. It's a process called enucleation. So now you have an egg cell that's basically an empty shell with all the cellular machinery to create life, but no genetic instructions of its own.
And then comes the transfer part of the name.
Precisely. They inject the nucleus from the donor dog's skin cell into that empty egg. So now you have a reconstructed egg that carries the complete 100% identical DNA of the dog you want to clone.
And from there, it needs a spark, right, to get it to start dividing.
It does. They usually use a tiny electrical pulse. It tricks the egg into thinking it's been fertilized. And if it works, it begins to divide and grow, just like a normal embryo.
Which brings us to the final step.
Implantation. That new embryo is transferred into the uterus of a surrogate mother dog.
And to be really clear here, that surrogate dog has zero genetic connection to the puppy.
None at all. She's the incubator. She carries the puppy to term and gives birth, but the puppy is a perfect genetic copy of the original donor dog.
So on paper, it's 1, 2, 3 steps. But
It's not that simple, is it? I mean, the reason this costs, what, $50,000 is because it's incredibly difficult with dogs?
that is probably the biggest understatement we could make. It is astronomically difficult. Far, far harder than cloning a sheep like Dolly or a mouse.
Why? What's so unique about dogs?
It comes down to their reproductive biology. Female dogs have a very specific, very short window for ovulation. And, this is the real kicker, the eggs they ovulate are immature.
Immature.
Yeah, they're not immediately ready for fertilization. They need to mature for a few days after being released. So trying to harvest eggs at the exact right moment for manipulation in a lab, it's a huge challenge. The timing is everything, and it's incredibly hard to get right.
So because of that, the success rate must be pretty low.
Abysmal, historically.
Yeah.
Even now, with all the advances, the success rate, meaning live births from implanted embryos, is often in the low single digits. 1 or 2%, maybe.
That's a good estimate. So you can imagine, to get one successful clone, you might need hundreds of eggs, multiple attempts at nuclear transfer, and several surrogate mothers.
Wow. Okay, that context is so important. The sheer amount of biological material and effort involved for one single puppy. We have to keep that in mind when we get to the ethics.
Absolutely.
But despite all these challenges, they did crack it. And the breakthrough didn't happen in the US or Europe, did it?
No, it came from South Korea. The big moment was April 24, 2005. That was the day the world's first cloned dog was born, an Afghan hound named Snuppy.
Snuppy, I remember the pictures. It was huge news.
It was a massive scientific milestone. It proved that these huge biological hurdles in canine reproduction could be overcome, and honestly, it validated the entire concept. It paved the way for the whole commercial industry we see today. Without Snuppy, there would be no $50,000 pet cloning services.
So the science is there. It's established, even if it's really, really hard. So let's pivot to the why. What are the advantages that drive someone to go down this incredibly complex and expensive path?
Well, the number one reason, as we touched on, is that emotional bond. It's about continuity. It's for the owner who had such a profound, once-in-a-lifetime connection with the dog that the idea of that bond just ending is unbearable.
So they're trying to keep that physical presence, that lineage going.
Exactly. It's an attempt to, soften the blow of death, to not have to say a final goodbye.
And I imagine this is even more intense for people who rely on their dogs for emotional support.
Oh, absolutely. For someone dealing with, say, anxiety or depression, a specific dog can be a lifeline. Their routine, their comfort, their non-judgmental presence, it can be critical for stability. Losing that animal isn't just sad, it's destabilizing. So for them, cloning can feel less like a luxury and more like an investment in their own continued well-being.
That makes sense. But the reasons go beyond just personal comfort, right?
Yeah.
There are some hard science arguments for it, too.
There are, and this is where it gets into breed preservation and genetics. One of the big arguments is the potential to avoid genetic diseases.
Oh, so?
Well, think about many purebreds. So many breeds are plagued by hereditary issues, hip dysplasia, heart conditions, certain cancers.
Right.
If you have a dog that lived to be, say, 15 years old and was perfectly healthy, free of all those common problems for its breed, that dog is genetically exceptional. By cloning it, you're essentially locking in that proven, healthy genetic profile. You're creating a new generation that won't inherit those known flaws.
So it's like a form of genetic purification, in a way.
That's a good way to put it. And that leads directly to longevity and preserving the best of a breed. A breeder with a champion show dog, one with a perfect temperament and physique. Cloning allows them to replicate those ideal genetics. It's a tool for enhancing the breed over the long term.
And I suppose for very rare breeds, it could be a way to prevent them from disappearing entirely.
Yes, that's the conservation angle. For endangered breeds, cloning could be a crucial tool to prevent extinction. It keeps their unique genetic heritage alive, which contributes to the overall genetic diversity of canines.
And we can't forget the scientific contribution itself. The process of cloning dogs, even if it's for commercial reasons, must generate a ton of useful data for veterinary medicine.
A huge amount. Every time they perform SCNT, every time they study a cloned animal, scientists learn more about how genes are expressed, how they're regulated.
So the insights go way beyond just the one cloned puppy.
Far beyond. The knowledge gained helps with research into fertility treatments, regenerative medicine, and genetic diseases for all animals. So in a way, every cloned pet contributes to a body of knowledge that could help countless other animals down the line.
Okay, so those are some really compelling arguments. But for every one of those points, there's a counterpoint. And this is where the conversation gets, well, really difficult.
It is. Because we now have to talk about the ethical cost, the financial cost, and the biological risks.
Let's start with the big one. The core ethical debate. Is this just unnatural?
That's the argument from a lot of critics, that it's a fundamental manipulation of life and death that humans shouldn't be involved in, that reproduction should happen naturally.
But the criticism goes deeper than just a philosophical objection, doesn't it? It's about animal welfare during the process itself.
It is. Remember that low success rate we talked about?
Yeah.
1 to 2%.
Yeah.
To get that one success, the process requires numerous surrogate mother dogs, and those dogs have to undergo hormone treatments to prepare their bodies, then surgical procedures to implant the embryos. Many of those pregnancies won't take.
So you could have a dozen or more female dogs going through all of this for one client's puppy.
Exactly. And critics ask, is the well-being and potential suffering of all those animals worth the outcome for one wealthy owner? It's a powerful question, especially when you think about resource allocation.
The money. $15,000.
At least. And that's where the ethical argument gets really sharp. Critics say, think of what that $50,000 could do for animal welfare in general.
You could fund a massive spay and neuter program. You could support a shelter for an entire year.
You could save hundreds, maybe thousands of dogs from euthanasia. So it creates this direct tension between the desire to replicate one specific beloved animal and the needs of the broader suffering animal population. It's an uncomfortable truth.
And it makes this a solution only for the very wealthy. It's not a grief solution for the average person.
Not even close. It's a service for the 1%, which adds another layer of ethical debate around privilege and access.
Okay, so beyond the ethics and the cost, what about the clone itself? Is it a healthy animal?
That's a huge question with no easy answer. There are very real biological risks.
Right.
The SCNT process is, well, it's traumatic on a cellular level. It's not a perfect, gentle process.
And that can lead to defects.
It can. In the early days of cloning other mammals, there were issues like large offspring syndrome, where the clones were born abnormally large, causing birth complications. There are also concerns that clones might have weaker immune systems or show signs of accelerated aging because the DNA they start with is from an adult cell.
So you could spend all that money and end up with an animal that is predisposed to health problems and a shorter life.
It's a definite risk, a significant one. The science has improved, but it's not a risk that's been eliminated.
And that brings us to what might be the most heartbreaking problem of all. The one that happens after the puppy comes home. The nature versus nurture debate.
This is, I think, the source of the most profound disappointment for owners.
Because you pay the money expecting to get your old dog back.
Not just his looks, but him, his personality, his quirks, the way he looked at you.
You expect to get the soul back.
Yeah.
But you can't clone a soul. You can't clone a personality. You only clone the genetic hardware. And this is where the science gets really fascinating. The term is epigenetics, right?
Exactly. Epigenetics. This is the crucial concept. So the DNA sequence, the genetic blueprint, is 100% identical. But epigenetics is like the software that runs the hardware. It's a layer of chemical switches on the DNA that tells the genes when to turn on and when to turn off.
And that software is written by life experiences.
Perfectly put, it's influenced by everything. The environment in the surrogate's womb, the nutrition the puppy gets, its early socialization, how you train it. All of these things flip those epigenetic switches differently.
So the original dog's genes might have the potential for a very calm temperament, but the clone's life experiences could mean those genes don't get expressed in the same way, and he ends up being more anxious.
Precisely. The potential is there, but the outcome is not guaranteed. So you get a dog that looks identical, but it's a completely different individual. It had a different birth, a different puppyhood. It has its own unique consciousness.
And I can only imagine the pressure on that little puppy to live up to the ghost of the dog it was copied from. That must be so difficult for the owner and, in a way, for the dog itself.
Yeah. It's a huge psychological burden. The clone is constantly being compared to an idealized memory. It's not a replacement, it's a successor. And many owners struggle to accept that distinction.
That's a huge insight. So let's shift from the theory to the practice. Where is this actually happening? What does the legal map look like for dog cloning?
It's a complete patchwork. The science has moved way faster than the law.
Let's start here in the United States. Is it legal?
Yes. There are no federal laws that ban or even specifically regulate dog cloning. It operates in this legal gray area. States could make their own rules, but none have banned it. So it's mostly governed by general animal welfare and veterinary laws.
Which feels a little inadequate for such a specific technology.
It does. Now, compare that to South Korea. As the birthplace of Snuppy, they've leaned into it. They are the global hub.
They have the best labs, the most experience.
Right. They've invested heavily. So if you're a wealthy person anywhere in the world who wants to clone your pet, there's a very good chance you're working with a company based in South Korea.
What about Europe? I'd imagine they're stricter.
Much stricter. In the UK, for instance, it's legal but very tightly regulated. The government keeps a close eye on it to ensure animal welfare standards are met, to try and prevent the kind of suffering we talked about with the surrogates.
In Australia is similar.
Very similar. They allow it, but with strict rules focused on responsible practices and minimizing any harm. They're trying to find that balance between allowing the science and protecting the animals.
Then you have a place like China.
Which is more of a Wild West situation. There aren't really any specific laws, but private companies are offering the service. That lack of clear rules raises a lot of concerns about ethics and what's actually going on in those facilities.
So it really depends where you are in the world. Now, commercially, this all really took off because of one specific pet, right? A dog named Missy.
That's right. The Missiplicity Project back in 2005 was the spark. Missy's owner was a very wealthy individual who poured a lot of money into the research. That project essentially proved there was a commercial market for this. It took it from an academic curiosity to a viable business.
And since then, we've seen it used for more than just grieving pet owners. There have been working dogs cloned.
Yes, the case of Nubia is a great example. Nubia was a decorated police canine killed in the line of
A
duty.
hero dog.
Absolutely. And her clone, Nubia's puppy, wasn't created to be a pet. It was created to preserve those elite working traits, the intelligence, the scenting ability, the drive. It was about quality control for a line of professional working dogs.
Which is a completely different motivation.
Mm.
And that brings us to the undisputed champion of dog cloning.
Yeah.
The one that takes this whole idea to a different level, Miracle Millie.
Ah, yes, Miracle Mill.
Tell us about her. She was famous even before the cloning, right?
She was. Millie was a tiny chihuahua from Puerto Rico. She held the Guinness World Record for being the smallest dog. We're talking just 1 pound and under 4 inches tall.
Wow. Just a little creature.
A tiny, unique animal, and her owner decided that uniqueness was worth preserving. So in 2011, Millie was cloned. They took a small skin sample and went through the whole SCNT process.
And it was a success.
It was. But that's not the amazing part of the story. The amazing part is the scale.
This is the record, right?
This is the record. Miracle Millie is the most cloned dog in history. She has been recreated 49 times.
Wait, 49. 49.
49 times. 49 genetic replicas of this one tiny chihuahua.
I don't even know what to say to that. Why? Was it for research? Or did the owner just want a lot of them?
It was likely a combination of things. Furthering the science, maybe creating a line of these tiny dogs for sale, or just the owner's profound attachment. But whatever the reason, that number 49, it just crystallizes the whole debate.
It really does. On one hand, what a feat of science. On the other, are those 49 puppies really individuals? Or are they just products manufactured from a blueprint? It's a really profound question.
It is.
So as we wrap up this deep dive, let's try to distill this down to the key takeaways.
I think the first and most important one comes back to that nature versus nurture point. Cloning gives you the genetic blueprint. It preserves the traits, but it does not give you the same personality.
You're not getting the same dog back.
You are not. And any owner going into this has to manage that expectation. You are getting a genetic twin, a new individual that you have to raise and get to know all over again.
And the second takeaway has to be about the choice itself.
Yeah.
It's a deeply personal decision, but it's one that forces you to weigh your personal emotional needs against some very significant financial and ethical costs.
Right. You have to ask yourself if the resources, the money, the science, the use of other animals are justified for that one outcome. It's a heavy decision.
And for the 99.9% of us for whom this isn't even an option, there are other ways to memorialize a pet. The sources mentioned a few alternatives.
Yeah, and they're becoming quite popular. Things like custom-made plush replicas of your pet, so-called plush clones.
So you get a little stuffed animal that looks exactly like them.
Exactly. It's a comforting physical object to have. And often, buying one supports animal shelters, so it has a positive impact. There are also things like custom pet portraits, immortalizing them through art.
So it's about finding comfort and closure without needing the biological replication, honoring the memory, not trying to recreate the individual.
I think that's what most people are really searching for.
Which leads us to our final provocative thought to leave you with. We've established that even with the exact same DNA, clones are different because of their environment, because of epigenetics.
They are biologically distinct in their lived experience.
So as this technology gets better and maybe even cheaper, we have to ask a really fundamental question. How far should we go in manipulating nature just to extend companionship? It challenges our very definition of what makes an individual unique. Is it just the code, the DNA?
Or is it the unrepeatable sum of their experiences, their life?
And when you pay that $50,000, what are you really trying to buy back? The blueprint or the story?
A fascinating and necessary question to ponder.
We hope this deep dive has given you a much richer understanding of this incredible, complicated world. Thanks for joining us. We'll catch you next time.